Lake deposits as paleoproxy records across the world. Hello, my name is Matthew Gutierrez, and today I will be discussing lake deposits as paleoproxy records as potential indicators for regional climate variability. The regions we will be covering today are from two different areas of the world, Russia and the Bahamas. For my references, I will be referring to the bibliographies I have created, bibliographies 1 and 2. As an introduction to lake deposits can be understood as originating in areas where lakes are or once were. In these lake environments, sedimentary layers accumulate, and these sedimentary layers have crucial information about past climate and environmental events, as fossils and other geological materials are within those sedimentary layers. Some of the remains that are preserved due to these waterlogged environments include microscopic plant and animal remains, fossils, and sediment from all over the surrounding areas, as well as isotopes of past lake waters. The two regions that we will be using as examples of lake deposits are on two different sides of the world and two different climates and environments. Our first region, we will be looking at Lake Baikal in Russia, and with our second region, we will be looking at the northern Bahamas and Turks and Caicos Islands at an event that occurred in the middle to late Holocene. When looking at these regions, you'll find different ways that lake deposits are utilized by scientists to understand past events. When looking at the first region, Lake Baikal in Russia, scientists utilize lake deposits to understand the isotope compositions of past salt water and to compare it to the isotopic composition of the current salt levels within the freshwater lake. Lake Baikal is the world's most voluminous, non-frozen freshwater lake. Interestingly enough, it is also the deepest lake in the world, as well as being the oldest lake, with sources estimating that the lake was formed 25 to 30 million years ago. Scientists within the study looked at the continental crust surrounding the lake as a way to understand the composition of Earth's layers, and Lake Baikal is able to provide a unique opportunity to scientists as the sedimentary records date all the way back to the Miocene, which is uncommon for lakes. Scientists handled two different types of sediment when looking at sediment samples, and this was done to target specific times and intervals in Earth's history. One of the sediment samples was a modern core top sediment, and the others were paleo samples from mud. When looking at the second region for lake deposits, we are taken to a much different environment in the tropical archipelago of the northern Bahamas. Scientists arrived at the Abaco Island in the Bayaco Archipelago, an area in which sinkholes are all too common. Scientists here studied a sunken cave that turned into a sinkhole late in the middle, say a sinkhole lake in the middle to late Holocene, and are looking to use this site and its lake deposits as a way to find a linkage to regional climate variability. To give background information about how sinkholes are developed and why the scientists are studying them at this location, sinkholes develop when caves collapse, and when this happens, there is a small chance that these holes fill up with the water and become lake-like environments. When looking at what sinkholes provide to scientists as paleoproxy records, sinkholes provide sediment cores that have immaculate reconstructions of past events, such as any environmental changes, hurricane activity, and more. After looking at the different sites of sinkholes in the Bahamas, scientists were able to find markers of certain environmental changes that were defined by a decrease in ostracod faunal changes. As stated previously, sinkholes provide opportunities to look at the isotopic composition of different sedimentary layers within the water. Lake deposits. As I conclude this presentation, I would like to touch on the overall importance of lake deposits as paleoproxy records, as well as give one good final overview of the ways in which our world is, and will continue to change due to climate change. Lake deposits provide scientists with opportunities to look at sedimentary layers that have been preserved in unique environments. Scientists can look at isotopes within the sedimentary layers, as well as fossils, and microscopic remains of fauna and flora across several different time periods. Lake deposits in areas like Russia and the Bahamas have shown how climate change has affected the regions across several hundreds of years, and what patterns and cycles there are within our Earth systems. These records will continue to serve us in the future by potentially giving scientists information about settings for habitable environments in the future. Thank you for listening to my presentation. Bibliography 1, Bibliography 2 for images.